Agentic AI is one of the most important topics in AI interviews right now, especially for roles involving large language models, AI assistants, and autonomous systems. Unlike traditional language models that simply generate text in response to a prompt, AI agents can do much more. They can reason through a problem, plan a sequence of steps, use external tools, remember past instructions, and even improve their behavior over time through feedback and reflection. In this video, we will walk through six of the most frequently asked agentic AI interview questions, and we will explain each one in a simple, visual, and practical way so you can understand and not just a definition but also the real institution behind it. Here's what we will cover: React pattern, reflection agent, utility based agents, planning agents, hierarchical agents, autonomous reasoning. Let's begin with one of the most fundamental agent patterns in modern AI: React. React stands for reasoning plus acting. The key idea is that instead of jumping straight to answer, the AI agent follows an iterative loop where it thinks first, acts second, and then uses the result of that action to think again. This makes the agent much more reliable when it needs information beyond what is already inside the prompt. Here is how the process works. First, the agent reasons about the problem and decides what it needs to know. Then it acts by using a tool such as a search engine, a database query, or an API call. After that, it observes the result returned by the tool. Then it reasons again using this new information. This cycle continues until the agent has enough evidence to produce a final answer. For example, imagine asking who wrote The Alchemist and when was it published. A normal language model might try to answer directly from memory, but a React agent would recognize that it should verify the facts. It might search for the author, retrieve the publication year, compare the results, and only then generate the final response. So the workflow becomes prompt, think, act, observe, answer. That's why React is so powerful. It reduces guesswork, improves accuracy, and makes the model far better at handling tasks that require external knowledge or real-time information. Now let's move one step further and talk about the reflection agents. A reflection agent doesn't just reason and act, it also evaluates its own performance. This is what makes it different from a normal React style loop. The process usually has three stages. First, the agent makes an initial attempt at solving the task. Next, it reflects on that attempt by asking questions like what was wrong, what was missing, where did the reasoning fail, how can the answer be improved. Finally, it stores that feedback in memory and tries again using those lessons. The important thing to understand is that this improvement happens through verbal self reflection, not by retraining the underlying model or updating its weights. Let us a coding example. Suppose the agent writes a Python code, but the first version has a bug. A reflection agent can inspect its own output, identify the mistakes, remember that issue, and generate a cleaner, more correct second version. So, if React is about gathering information and acting, reflection is about learning from your own mistakes and improving future attempts. That makes it especially useful in tasks that require iterative improvements, such as code generation, reasoning tasks, planning, and problem solving. Next, let's talk about utility-based agents. Utility-based agents doesn't just ask, "Can I reach the goal?" Instead, it asks us something much smarter. Which option gives me the best overall outcome? That is the core idea behind utility-based decision making. The agent evaluates different possible actions using a utility function. A utility function is simply a scoring mechanism that assign a value to each possible outcome. The higher the score, the more desirable the outcome. This means the agent can compare not just whether an action works, but how good that action is relative to the alternatives. For example, imagine choosing between four travel options: fast but expensive, cheap but slow, balanced choice, highest reward. All of them may get you to the destination, but utility based agents will compare cost, time, reliability, and expected reward before choosing the one with the best total value. This is especially useful in uncertain environment because the best decision is often not the one that simply achieves the goal. It is the one that gives the highest expected utility. So the key idea is goal-based agents ask, did I succeed? Utility-based agents ask, which success is best? Now let's look at the planning agents. A planning agent is an AI system that thinks ahead before it acts. Instead of reacting immediately, it creates a roadmap from the current situation to the desired goal. This is what makes a planning agent useful for longest, more structured tasks. The process usually includes five steps. First, the agent understands the goal, then it breaks the goal into smaller subtasks. Next, it evaluates a different strategy or paths. After that, it chooses the best plan. Finally, it executes the plan step by step. For example, if you ask, plan the best route for a delivery truck, a planning agent won't just pick the first available road. It may consider traffic, fuel usage, delivery deadlines, road conditions, and route efficiency before selecting the best. That's why planning agents are so valuable in robotics, logistics, autonomous navigation, and any system where the sequence of actions matters. So, in simple terms, a planning agent doesn't just respond; it organizes actions into a strategy. Let's move to hierarchical agents. Hierarchical agents is organized like a company or a team structure. At the top is a manager agent or a supervisor agent. Its role is to understand the overall objective, break it into smaller tasks, assign those tasks, monitor progress, and combine the final outputs. Below the manager are multiple worker agents. Each worker focus on a specific type of task such as searching for information, retrieving data, performing analysis, executing actions. Instead of one large model trying to do everything alone, a hierarchical system distributes the work across specialized agents. This creates several advantages: better scalability, better specialization, better parallel execution, better efficiency on a complex task. For example, one worker might search document, another might summarize results, and another might verify facts. The manager then combines all the outputs into one final solution. This architecture is especially useful in a complex real-world system where coordination matters more than a single response. Finally, let's talk about autonomous reasoning. Autonomous reasoning is the ability of an AI agent to make decisions independently with minimal human supervision. This is one of the defining characteristics of a modern agentic system. Observe, analyze, decide, act, learn from feedback. The agent continuously receives information from its environment. This may include a user request, documents, APIs, sensors, databases, or search results. Then it evaluates possible actions, reasons about its goals, chooses the best next step, uses tools to carry out that action, observes the result, updates its memory, and repeats the cycle. The most important things here is that the agent is not just reacting, it is continuously reasoning, adapting, and improving based on what it learns. That combination of perception, memory, planning, reasoning, and tool use is what allows an agent to behave autonomously. So, autonomous reasoning is really about enabling an AI system to solve problems on its own, step by step, while adjusting its behavior as new information arrives. Let's quickly recap. React combines reasoning with tool use. Reflection improves performance by learning from self-critic. Utility-based agents chooses the action with the highest expected benefit. Planning agents think ahead and follow structured plans. Hierarchical agents coordinate multiple specialized agents. And autonomous reasoning allows AI to perceive, decide, act, and learn independently. These ideas form the foundation of modern AI agents, and they appear frequently in interviews for roles involving large language models, AI assistants, and autonomous systems. If this video helped you, make sure to like, subscribe, and share it with someone preparing for an agentic AI interviews. Thanks for watching, and I will see you in the next video.